Okay, we are back. I was thinking of just calling it a day early, but then I realized this is not going to get done until I do it. So let's get doing it. So I think that this was, we figured out that entropy was the likely thing wrong, which is weird because entropy is like the simplest bloody piece of this. Go figure it out. So we have the Ford's kernel, and the Ford's kernel computes the loss. And there's the entropy is right there. Okay. So then I was supposed to block off the other gradients. Grad values, grad logits. Okay. 0 logits for this. Cool. Let's see if this does anything. And if not, then we get confused. The entropy is supposed to be the really easy calc. And no. Cool. Let me try one other thing just to be sure that I did this correctly. Make sure it's not doing the value grad somehow. Okay, it's not. So somehow, it seems like somehow our entropy grad, which is supposed to be the simple one, is wrong. Okay. But it's right in the forward path, so then the gradient of the entropy is somehow wrong. Unless I didn't compute log p. Go look. Make sure that we didn't mess this up. Do log p. Okay. It doesn't look like I messed with anything, right? And then it's just straight up delogits. This. To make sure we didn't mess with anything other than the grads. Grad values. Grad logits. There we are. And we'll just make sure that this is exactly what I think it is. Still no. Alright. Make sure that it's not this negative. I don't think it is. It's possible. Stupid thing needs to compile faster though. The deal I'm gonna make myself here is that if I get the all 4 kernels, this is the last kernel, so if I get this working and training works, I'm done for the night. That's the deal. Oh, what's this? That's just a comment. The entropy. Oh, here it is. Okay, now we are at 1e minus 6. Which is still off. Like, substantially. Now we can start... Okay, well, first of all, this is an XF. That could be it right there. I doubt it, but it could be the XF. Entropy minus log P. Didn't change it. Okay. Let's go look for entropy. This is also XBEF up here. That's the only thing I can see. Entropy should match very, very closely. Oh. There's so many of these, like... Yeah, there's so many of these little ones that I just must have missed. There. Alright, well, I mean, it's... The thing with 1e6 is 1e6 can just be float screwing with you. You have to actually make sure we're using double functions for everything. Like, obviously, I don't want to ship this in double precision, right? But, like, for debugging it... And 1e minus 8. I'm still not perfect. Let's see how I'm computing this normally. So I just do negative p log p dot sum dot mean. So is the error in p log p? All right, let's try some other stuff here. Log p. New log p. Let's just set 'Like this. There's new log p. (108) diff. New log probs. Is it sum of one dot mean? Is this correct? Is it dot sum? Is it dot mean? Divide by n times t. Okay. Let's see. Why is that 2048 by 64? Oh no, that's correct. But then, isn't it just return dot mean like this? Am I wrong? Ah, there we go. Yes. But wait, is it just this then? 70 minus 6. Is it just like this? To mean difference? I don't think so. Guess we'll see. Is if p log p. I set this to thread loss. This should be correct though. Wait. Prob's new. I have as the entropy here. Oh. Hmm? Okay, so this is actually the very close one. What is it? Log prob. Huh? I'm confused. The correct entropy formulation? Is this how I do it? And I might have done it wrong in here. So it has logits and actions. Wait, what? Entropy of normalized logits. So it's logits minus logits log sum x. Entropy is... Where'd it go? Let's freaking cleaner, I'll do it. Okay. Okay, let me just make absolutely freaking sure. Let me just make absolutely freaking sure before I go drive myself insane doing this. Gradient has values. Still not right, though. So it's screwed either way. You'd be kidding me. Okay, fused. Forward pass is right. We'll see if this does value. Okay, the value loss is correct. That is like completely freaking correct. Okay. Now we can ignore this. Do the entropy. Coef. Take out rad of the value. Okay. Take out this one. Okay, and this gives you 1e minus 6. Hey, FBR. I'm trying to fix it. Driving me insane. Log softmax. Then exp. It says my forward pass is correct. Okay. But then it says my backward pass is very slightly off. No, it's at this point, I'm tired and I want this to be solved, man. Exceedingly tired. Okay, let's see where P comes from. Exp L minus log sum exp, right? Log sum exp. Ah. You see? We have the 1e minus 8 here in the log sum exp. I don't think we have that in our version. How do we now have it slightly off? Oh, okay, it's non-deterministic. Lovely. Interesting. Numerically, it's just like not identical. Okay, let's take the real one though is this. Start with this. Policy loss. Okay. You could have also looked up any of the number of like very well written articles on the topic. You dingus. Okay, yeah, so it's definitely this one. The policy gradient loss is like way the hell off, right? Way the hell off. And now, I guess we can try... There are blog posts that will do that for you. Like all sorts of posts like this. It's not called annotated transformer. It's just one of the random posts I happen to know of the very many posts on this. Like, you picked a topic that probably has the most well-written content about it in ML. And then instead of using it, you decided to get a fucking shit language model that lies to you half the time. I don't know, man. It's a pet peeve of mine. It's like when I get multiple people on the stream saying, "Hey, I put PufferLib into a language model, and it told me like I should use the Puffer, the PufferPuff class or whatever." It's like, why the fuck do you ask the language model? I put time into making these docs not shit. don't know what it's called. Then use the LLM to point you to resources that don't suck. Like, use it as a search engine. Don't use it to try to replace the materials themselves. It's just going to give you a worse summary. It's like there are a relatively small number of very high quality resources out there that you should use. Okay, interesting. So, guess we do this then, huh? What the fuck did I do wrong? Okay, let's go back a little bit on this. What did I do? Had this word before. What? Is this wrong? Getting tired. Push a little bit more though tonight. Was it this negative? Yes. Okay. Now we just very, very carefully add some stuff back in. We're gonna do this just painstakingly. Because I don't I basically don't have any brain cells done for the night. I don't have any brain cells left for the night, so we're just gonna do this like painstakingly. So I don't even have to think about it. Just a bad gradient. I see. Interesting work. Yeah, so this is high perf kernels for PufferLib 4. We're gonna try to get 10 million step per second RL. And right now I'm just fighting numerical issues, like very small bugs with gradients. So this is a pretty large bug. For some reason, I'm just not doing clipping backwards. I'm too tired to do this manually, so let me just do... And this is simple enough that even a dumb language model shouldn't screw this up, I would imagine. Yeah, it just wasn't doing the clipped loss. So I was calculating clipped loss, but doing unclipped grads. There we go. Now we actually have correct grads. Now I can do... Let's see if we are lucky enough that this whole thing just works. I should just be able to do like this. Too freaking long with the compile time. I probably should like bother to fix that. I don't know. This whole setup is just really annoying to me. Because like I'm somewhat out of my element here. If I were building an environment, for instance, I would have instant compile times. But because I have to deal with torch and everything, here. This. And this one here. Yeah, so it's like this, right? This bot. So I think that should be correct. Of course, we still have the entropy gradient being a little stupid. Okay. E minus 12 on the clipped loss is really nice. Let's do the entropy grad now. Grad. And we'll see how bad this is. Six. Do the full loss. P. That. And we have to enable this. Where's my value gradient? There we go. Miss Kuda. Heh. If I were just working in CUDA without the PyTorch mess bound to it and slowing everything down, it would be chill. Lib part of your PhD. Heh. I finished my PhD about a year and a half ago, a little more at this point. This library is now the fastest performing and the fastest growing library in reinforcement learning. I work on this full time. This is when I started working on it full time right here. And we're now training at several million steps per second. And that's in the Python backend. And now in Puffer 4, I'm working on adding a C++ backend with a bunch of custom kernels that should get us to 10 million steps per second training. Whole bunch of other new things coming soon as well. All open source. All here on puffer.ai. Star the repo. It helps feed the puffer. He likes stars. To feed the puffer some stars. Why you are stuck with torch? Because I'm trying to write non-trivial networks. So if I don't have a torch bind, nobody will use the library. If I try to do all CUDA from scratch all at once, it's not going to frickin' work because I'm trying to implement more than just like a 2-layer MLP. So the only thing I really can do is I can just incrementally like eat away at torch and fuse a whole bunch of operations into custom kernels and then kind of just like get performance back bit by bit and then still have the torch bindings. You know, it's technically possible I could do this whole thing just with custom ops that are just bound to the torch front end. Very nice. Thank you. Yeah, this is something of a crusade here to like make RL fast and sane and broadly accessible and useful across a number of areas of science. Magnum opus, if you will. Oh, this is already training with the PPO loss. It's stable. Cool. So the entropy grad could be a little bit smoother. But this actually works. That's kind of awesome. Autonomous marine vehicle? That's cool. You're gonna train a puffer bot with the puffer? Check my guides on X. If you click my articles tab, all my best advice is in there. Opinionated RL guide and then my programming and ML guide. 2 best pieces of content. Well, I definitely want to save this now before I break anything. Thank you. You inspire me. I got you. I'm a little too tired to be inspiring at the moment, mind you. I kind of just been grinding this. Were you around earlier for the morning run story? I froze myself half to death this morning trying to run. I forgot the weather forecast. I thought it was like 50 outside, so I was like, "Wow, I'm really cold. That's weird. I can't feel my hands." Yeah, apparently I went running in like, you know, mid high 30s with like crazy wind chill in a t-shirt and shorts. That's why I'm still all wrapped up. I'm like friggin' still cold from this morning somehow. This is on the radar, considering been some interesting things being applied to what I'm currently looking into. Awesome. Yeah, I mean, if you check out the stuff that I have, the content around this, it's actually surprisingly easy to get into a lot of it now. It used to not be the case at all. It used to be just like the hardest thing ever. Now it's pretty good. Now it's pretty good. Go check entropy again. What time is it? It's not even 8 yet, right? Yeah, so I can work a little bit more on this. Benefits of the back end. If the user cannot set a custom torch model, nobody will use my library. Like, you literally can't do RL that way because you can't have a one-size-fits-all torch model. I also am not generally a fan of, like, abstracting shit from the user. I like to make things low-level and clean. Boy, I'm in Turkey, writing C and C++. It's good. You should be. Build some cool environments. Build some cool projects. Learn some stuff. Oh yeah, I have to merge some. I have some PRs open on this. But if you're looking for something dumb and fun to do, I made this site onlyfish.ai where you can submit puffers to this site and I can merge them in. So you can train a puffer and try to get a puffer that behaves differently from the other puffers. And then you can feed them stars. I kind of hacked this environment of ours, and then I made it like interactive and stuff. It's only fish. That was for hitting 20k followers. That was like the special event. I thought it was amusing. I found it very amusing, in fact. It's only fish. I was gonna make it only fins, but OnlyFins, the domain was taken for a Finnish dating site. I'm not even making that up. That sounds like super made up, but you can look it up. It's like an under construction Finnish dating site. That was pretty funny. Then don't... Honestly, I hate C++. You don't need C++, man. Just write M's in C. All our M's are in C. The only reason I'm doing any C++ now is because I have to for the torch bindings. You're gonna see that by the time I have this thing built for like Puffer 4, it's gonna be as close to C style everywhere as I can possibly manage. Okay, so this is probably just our log softmax. Yeah. Very difficult to advance. 2 years while studying. What do you need to do to apply and be accepted? So to be honest with you, basically anything that you're able to do, like at any reasonable level, you're going to be compensated way, way, way better in the US than in Turkey. So pretty much if you get anything reasonable here from like a legitimate company that's not just trying to like farm visa workers under bad conditions, you'll be doing well off immediately. And then from there, it's mostly about like, what are you actually passionate enough about to become near the top of the field, right? There's pretty much no upper ceiling in the US. It's just about how good you can get, and of course, what you can do with it. So, if you work hard and you're ambitious, I always recommend people try to come to the US because it's the country for it. Is that how you're able to work on Puffer full time? Well, I'm a U.S. citizen. I'm American born and raised. Um, and no, so with Puffer, all my stuff is open source, but we build like custom high performance simulations for companies. We do like dedicated R&D support. So we do have a few things that we offer. I mean, Puffer's a relatively new company. I've been doing this less than 2 years, and already we've made pretty much all of our RL like 100 to 1,000 times faster, depending on the project. So right now we have a couple companies that we do stuff with. We're growing that, but we're not like trying to grow it super quickly, right? I'm mostly focused on the research. And then when companies come to us like, hey, can you do this type of a sim? We price it, and we have a few contracts like that. And that side will grow a lot more in the future, but for the time being, I'm really focused on research, and it's mainly like, I'm not really advertising it a ton outside of just having the stuff that I do on X. And then the companies that are excited about this stuff, they find us anyways. Pretty much it. Okay, good enough for now. Be visa issues on both Turkish and US. What, they don't let you leave? Contributing to projects. Oh yeah, absolutely then. If it helps you, by all means, build cool stuff and submit to Puffer. We're very happy to see that. And Puffer has, as open source goes, it's a very legit project. What's going on here? We had this thing working. Oh, there we go. Little unstable. Does train though. Yeah, you'd like RL to be off the shelf, but it's not off the shelf tech, man. This is like actually hard. It's more off the shelf than it used to be. But it's still hard. And we do have, like, we have a default policy that'll work for, like, a lot of M's that we use, but, like, it, like, your end would have to have flat state data, basically. So custom encoders are still very much a thing. Okay, I'm really not loving the numerics here. I mean, we can't see the losses, right? Yeah. It does train, but the numerics are not amazing. Mostly the ent coef, I think. Yeah. Alright, so the entropy is still a little janky. I think I'm gonna call it a night, though. Like, we've gotten it to be in a pretty good spot. We have, like, one more thing maybe to fix on the numerics. They're pretty damn close to torch. This is all the entropy right here. And I need some rest, so thank you for tuning in, folks. All my work's free and open source. If you'd like to check it out, puffer.ai, star the repo to feed the puffer. Discord if you want to get involved, and X for educational materials, research, and the like. Good night. Integrate puffer into autonomous marine RL. That looks